You know that integers are all the whole numbers and their opposites, including 0. And if we kept 0 in the center and we took the number line, a number and its opposite are mirror images that look at each other. So 1 and -1 are integers that are opposites. 2 and -2 are integers that are opposites. Well, just like any other numbers that we have in our number system, we can add, subtract, multiply, and divide integers. So we're going to start our journey today with adding integers. Now, because integers can be on a number line, we can always use a number line to add them. But you can see instantly the moment we add integers into our math background, suddenly we have a lot of problems that we can solve. So if I have 2 plus 3, -2 plus 3, 2 plus -3, and -2 plus -3, all those are different integer addition problems whose answers are going to be different. Now, if I were going to use the number line, the first number in my expression would be where I start on the number line. Addition means I always have to face towards the larger numbers, and the second number is how many steps I'm going to walk. And if it's a positive number, I'm going to walk forward. If it's a negative number, I'm going to walk backwards. So if I start here, I'm going to begin at 2. I face towards the positive numbers, and I'm adding a positive number, so I'm going to walk forward 3 spaces. 1, 2, 3. My answer becomes 5. Versus this one, I'm going to start at -2. I'm still adding, so I've got to face the larger numbers. I'm adding a positive number, so I'm going to walk forward 3 spaces. 1, 2, 3. I come out at +1. Here, I'm going to start at 2. I'm going to face towards the positive numbers, but I'm adding a -3, which means I have to walk backwards. 1, 2, 3. My answer becomes -1. And here, I'm going to start at -2. I'm facing towards the larger numbers because it's addition, and I'm going to walk backwards 3 because that's a -3. 1, 2, 3. Notice, using all the same numbers, I'm coming out with different answers because of my integers. Now, I love using the number line, but sometimes we need to have some other methods because we don't always have access to a number line. So you have learned that absolute value means the distance a number is from 0. Well, I can use absolute value to also add integers. If I have -54 plus 40, well, all I do is I change that into a subtraction problem because I'm finding out the difference between the distances of -54 and 40. So remember, absolute value means the distance a number is from 0. Well, the distance that -54 is from 0 would be 54. The distance that 40 is from 0 is 40. So if I take 54 and I subtract 40, I'm left with 14. Now, how do you know what is going to be your integer sign, whether it's going to be positive or negative? Well, whatever the biggest number was, it takes that symbol for that number. Since -54 is bigger than 40 when we take a look at just the value of the number, that has to become a -14. So that's another way you could do it. Probably my favorite way to do it is through algebra tiles. Now notice, I'm making a big deal between black and red. I always keep my whole numbers black. I keep my negative numbers red. So positive black, negative red. And I'm going to do that all the time. It helps me visualize what happens. So I could take these same problems. Now, algebra tiles are a way for us to be able to see positive and negative numbers. So black always represents my positives. Reds always represent my negatives. So if I had 2 plus 3, that means I'd have 2 blacks plus 3 blacks. And addition means push together. So how many do I have in all? Well, I have all blacks, so I must have 5 blacks. There's my 5. Sometimes we're going to get a mixture of blacks and reds. And when we have a mixture of those, a black and red together make a 0 pair. They actually equal 0. It's like they disappear. So if I have -2, that means I have reds. And I have +3, that means I have blacks. Well, instantly when I go and push those together, I can see that this red and this black disappear. And I see this red and this black disappear. Well, what's left? Well, just a black 1. So I say that's a +1. If I look at this one, I have 2 blacks and I have 3 reds. Well, again, we have 0 pairs. So I see this black and this red disappear when I push them together. And I see this black and this red disappear when I push it together. What do I have left? I have a red -1. And then this one I have -2 plus -3. Now notice they're all reds. So these 2 reds and these 3 reds are pushed together. What do I have left? Well, I have 5 reds. That's got to be -5. So I love algebra tiles because I really like the visual part of it. Remember, those 0 pairs cancel each other out and make numbers disappear. So choose the method that you like. Any of them work. Find one that you're probably the best at so that you can really become accurate with these integers. Good luck. Enjoy adding integers.